Okay, what I want to show you on this video is this flow chart that you're going to be using, that you will want to use pretty regularly on the review assignment over the next couple of days. You start up here in the upper left-hand side, and I just want to work through a couple of these factoring problems, and I want to go through the reasoning of the chart and see if you can understand how to use it. So, because basically we've learned how to factor by grouping. We've learned how to factor using hangman. We've learned how to factor using special formulas. And today, on this video, I want to show you exactly how to know when to use what. So if we're looking at this first example, we have 2a squared minus 9a minus 5. It's a trinomial. We're going to start up here on this upper left-hand side. So let's go ahead and read this. It says, is there a common factor that appears in all terms? So we're going to look at this. Is there a greatest common factor in 2a squared minus 9a minus 5? There's no common factor. There's nothing that will multiply into all of these or divide into all three of these numbers. So we would say no. Okay, so then we're going to come down here where it says no, and we're going to follow this flow chart down to here. It says, is it a 4-term polynomial? Well, this polynomial only has 3 terms. So we're going to keep going on the yes, or on the no side. I'm sorry, the no side. If we come up here to no, it says, are the first and last terms perfect squares? So now I'm going to look at 2a squared and 5, and neither of those are perfect squares, so I have to say no. So I go down here to no, and it tells me I must use hangman. So that tells me that on this problem we need to do the hangman. Sorry, I made that a little narrow there. Okay, where we have 2a squared minus 5 on top and then negative 9a on the bottom. 2a squared breaks down into 2a and a. And then for 5, let's see, we want 2 factors of 5. I think the 5 is going to have to go here and the 1 is going to have to go here. And we'll make the 5 negative. I think that's going to help us work it out. So we're going to get negative 10a and positive 1a, which does in fact give us negative 9a. So then our factors for this problem are 2a plus 1 and a minus 5. So those are my factors. So I had to do hangman to get these factors. So my flow chart, I went through that, it told me that that's what I needed to do. Now let's look at number 2 here. Number 2 says 8x squared minus 16x minus 42. So again, we're going to look at our chart here. It says, is there a common factor that appears in all terms? So we're going to look at this. We have 8, 16, and 42. The first thing that I recognize is that all 3 of these terms are even numbers. So I know that there is something that can be factored out in all 3 of these terms. So you have to be very good about knowing your factors and knowing which each of the factors are in all these bigger numbers to see if there's a common one. And there is in fact a common one. So let's read what the chart says to do. It says yes. So then we come out here and it says go ahead and factor out the common factors. So we're going to go ahead and do that before we move on. So we're going to take the 2 out of here. And then this brings it down to 4x squared minus 8x minus 21. So now I have factored out the common factor. So now let's see what it says to do next. Then it asks us, is it a 4-term polynomial? Nope, this one's 3 terms. So we come up here to the no. Are the first and last terms perfect squares? We look at this. We have 8 and 42. Go down here to where we factored it out. 4, 21. 4 is a perfect square, but 21 is not. So we have to say no, which brings us down to use hangman again. So we're going to use hangman. On what's left. On the part that's left, we're going to use hangman. So we get 4x squared minus 21 on top, negative 8x on the bottom. I'm going to pick up a pencil right here because I may make mistakes here because there's a couple of factors. So we have x and x. 21 is probably going to be 3 and 7. And then we have to put a 4 in here. Let's put 2 and 2. Let's just try that. It's going to be 6 and 14, which the difference in 6 and 14 is 8. So I believe this will work. The 7 will have to be negative, the 3 will have to be positive. So that'll give us 6x and negative 14x, which does in fact give us negative 8x. So our factors are 2x plus 3 and 2x minus 7. And then also you have to bring this 2 that we factored out back down here. So this is the factored version. Okay, let's do another one where we use the flow chart here. We have 9z squared minus 36. So let's look and see the first question. Is there a common factor that appears in all terms? 9 and 36, if we think about those numbers, you should be able to figure out that 9 times 4 gives you 36. So 9 is a factor of each of those. So we've got to factor that out before we can do anything. So we're going to factor that out. So we have a 3 that's got to come out. And then what's left here is 3z squared minus 12. No, I'm sorry, we're not factoring out a 3. I apologize for that mistake. We are factoring out a 9. That will make a lot more sense. So then we're left with z squared minus 4. Okay, so I factored out a 9. That leaves us 9z minus 4. So now let's go to our next question. Is it a 4-term polynomial? Nope, this one's 2 terms. Are the first and last terms perfect squares? Let's look at it. We're not concerned with the 9 right now with perfect squares, but this is z squared and 4. And these are, yes, in fact, perfect squares. So if we look at our thing, it says, are they perfect squares? Yes, so we're going to use these special formulas. So, and these you will be given on the test, the special formulas. And you will find out that the formula that you need to use is a plus b, a minus b. We just did this yesterday. And then a is going to be square root of z squared, which is z. B is going to be square root of 4, which is 2. So then you end up with z plus 2, z minus 2, and then you have to come back and put back the 9. So we have to put the 9 at the beginning of that. Okay, example 4, we're going to look at this flow chart. First we need to look, this is always the first step. Is there a common factor that appears in all terms? If we look at our numbers, 6, 3, 24, 12. We know 3 is a factor of all of those numbers. So yes, it's going to be a 3. So we're going to take a 3 out of all of these. That'll leave us with 2x cubed. Basically, guys, we're dividing all these by 3. So, and then plus x squared plus 8x plus 4. And now we're going to factor what's left inside here. So let's look at the next question. Is it a 4-term polynomial? This time we're going to go with the yes. So then it tells us we must factor by grouping. And in the 9-8 notes I showed you how to do that. You want to look at these first 2 terms and see what's common. If you look at these, what's in common is just an x squared. And then what's left, if we take out an x squared, we are left with 2x plus 1 there. Then we're going to do a factor of these 2 terms. They have a common factor of 2, a positive 2. And if we take a 2 out of here, we're left with, oh, I'm sorry, it's not going to be a 2, guys. I'm sorry. We're going to take out a 4. We're going to take out a 4 because 4 is a common factor between 8 and 4. So I'm sorry about that. So then we get 2x plus 1. And I knew that I was messed up because this wasn't going to come out the same as this one. And they do need to come out the same. So now we just write our factors. We have to include the 3. So 3 is one of our factors. And then we want the GCFs. So we have x squared plus 4. And then 2x plus 1. So that is how this flowchart is going to help you study for this test. Now, unfortunately, you're not going to be able to use the flowchart for the test, so you've got to learn as you go. You've got to, over the next 2 days, as you're doing these factoring problems, you need to learn as you go on how to use this chart. It is a great study tool, this flowchart, but you still need to know the information on this on your own. But you need to know the flow. You need to have this memorized. You need to know how to do all of this. Thank you for listening on a review of factoring.